Okay, so the very first one that we're going to look at is a graph of volume and pressure. So pressure versus volume. As we change our volume, how does the pressure correspondingly change? So you guys may know this relationship from chemistry. You don't really have to know the relationship. This is just kind of giving you some data that we can practice this idea on. But so over here, I came in here and I graphed this graph for you. For some reason, Google Sheets won't let me do an inverse graph. I don't know if I just can't find it. But so this looks like an inverse relationship. So this looks like as our volume increases, our pressure decreases. So we kind of have this nice inverse curve. So that inverse fit that we're used to. So we can say over here that the pressure, so on our y-axis, is inversely related to the volume. So we have this pressure is related to 1 over v, and I wrote this related to because there's obviously some sort of something in there. There's some sort of factor that's relating them. There's some sort of constant. So I don't really know what that constant is. If I look at this graph right away, I cannot find that constant. There's nothing that I can do to this graph where I can say, oh, okay, instantly I see it. I would have to plug it into some sort of better graphing feature, like maybe Desmos, graph it on Desmos, and then say, hey, Desmos, I'm going to fit this with an inverse fit. And then from there, I'll be able to find whatever the relationship is between those two, whatever this factor is that's relating the rest of them. So whatever like our slope equivalent is, but we don't have a slope here, so I can't calculate anything. So this is not immediately useful to me. So I'm going to say that there's some sort of factor, some sort of constant here, A, but I don't know what that is. I'm not able to find that A. But what I am able to do is identify this as an inverse relationship. I'm able to say, okay, well, P is inversely related to V. So really I can write my equation, and I'm going to switch over so you can just see this. My equation is P equals A times 1 over V. So I have this relationship, and again, A is just a constant. We don't really know it right now. I'm just going to write over here, A is a constant. So I don't know it, but really my whole point of doing this is so I can find A pretty easily. So I can say P is equal to A times this 1 over V. And what I can do is I can identify this as an inverse function. I can say P is related to the inverse of V. So what I'm able to do is if I look over here, when I have this inverse function, if I kind of create a substitution, let's set up a substitution right here. If I graph P is equal to A times X, that looks a lot like a y equals mx plus b equation. I have pressure on my y-axis, some sort of slope, A, m, so slope, right? Or maybe I'll do it like this. Mx, and then we're saying, okay, well, we don't have a b here. We're just going to say we don't have a y-intercept. So we're saying, hey, this looks a lot like a linear graph. If we, instead of graphing 1 over something, 1 over v, we just graph this x instead. So what I can say is set up the substitution where x is equal to 1 over v. X is equal to 1 over my volume. So let's do that. So what we're going to have to do is we're going to have to go to our Google Sheet, and we're going to have to actually calculate that. So really quickly, we haven't used Google Sheets too much in this class. So what I can do is I can create a column over here for 1 over volume. And then instead of, sure, you can like calculate each one out with your calculator, but that's kind of tedious. What you can do is to set up an equation to make something happen is you could write in this little cell over here equals, and it'll say, oh, I recognize that you want to do some math now. I see that you've typed in equals. That tells you that you want to do some math. So we want this to be equal to this column to equal 1 over the volume. So what we're going to do is we're going to say we want this whole column to equal 1 over the number in our volume column. So that will calculate it. So that has calculated 1 over 0.1, and based on our math, we know that that checks out. And then if we don't want to calculate the whole thing, if we don't want to like type that in like, oh, equals 1 over this and blah, blah, blah. If we don't want to type that out, what we can do is just kind of grab this little, on the bottom, this little square, drag that down, and now we have our values. And I'm going to pause this really quick. What I want to do now is I want to graph volume, 1 over volume, and pressure. But Google Sheets is always kind of, let me try it out really quick. But Google Sheets is always pretty finicky with me. Oh, that time it did it. Cool. So we see, oh, I graphed pressure versus 1 over volume, and now I have a linear graph. I have a linear relationship between these two. If I put in a line of best fit, so if I go to click on my little data points, I click on customize, I go down here and it says, okay, trend line. I can add a trend line. If I click on use equation, it will show me my relationship. And I want to try to scale it, but I don't know if that's possible. Whatever, who cares? But I see, hey, these points are very, very linear. These points are kind of lying in a line now. And I have this linear equation, pressure equals 4 times x. So let's come back over here and write some stuff about it. So over here, my linearized mathematical expression is pressure equals 4 times x. So we found that our a value is equal to 4. And then what I can do if I want is I can sub back in and say, okay, well, I know that x equals 1 over v, so I say p equals 4 times 1 over v. And really the whole point of that is we were able to figure out the slope very, very easily because the graph told us. But if we just came across this graph, where we said, okay, this is like rise 4, I'm just kind of extrapolating our data, and then that's 1. If we look at this graph, we'd be able to immediately be like, oh, I see that as the pressure, as 1 over v increases, our pressure is going to increase, and it looks like it's changing at a factor of 4. So we could say immediately p equals 4 times 1 over v. So we could do that pretty easily based on our new graph. If we came across this graph, it would be very, very difficult to figure out this like change factor, this factor of change. So that's a very difficult thing to do. But with our new linearized graph, and even if our scale was a little bit better, that'd be a little bit more helpful. But so if our scale was a little bit nicer, we'd be able to figure out right away how pressure and 1 over volume are related to each other. So that's why we want to be doing this. And that's kind of what I want us to try with the other one. So I'll walk us through kind of what I want you to do next is on sheet 2, we have position in meters versus time in seconds. So we kind of have this fit. I want you to try this out. So kind of pause the video here, try this out, and then what I'll do is, or I guess not pause it, in the next video. So try it out, and then start up the next video once you feel like you figured it out. So then you'll be able to check your work in the next video, and yeah, and then I'll see you in the next video.